Alright, so this is section 5.4, which deals with polynomial and rational inequalities. Basically, a polynomial inequality is any equality with a polynomial in it that you can write in the form f of x less than 0, f of x greater than 0, f of x less than or equal to 0, or f of x greater than or equal to 0, as long as f of x is a polynomial function. So the very first example we're going to do is we're going to actually solve a polynomial inequality by looking at a graph. So it asks us to solve x plus 3 times x minus 1 squared greater than 0 by graphing the function f of x equals x plus 3 times x minus 1 squared. So I'm basically just taking what's over here on the left-hand side. I'm just putting it in as a function, and I'm going to graph it in my calculator. Here's my calculator. I'm going to y equals. Let me clear out all of these things really quick. And so I'm going to put in there x plus 3 times x minus 1 squared. I'm going to hit zoom 6. That way it zooms it back to a normal window. So there is my graph. Now looking at this graph, this is a graph of just this side. My inequality says I want to be greater than 0. If this function is greater than 0, is it above the x-axis or below the x-axis? Well, if it's greater than 0, it's above the x-axis. So we want to write intervals for all of this stuff that's above the x-axis. Now in order to do that, I need to know these spots where it crosses or touches the x-axis. This one right here and this one right here. If I hit the trace button, I can put a cursor on here and I can actually move it. I think this looks like -3, so I'm just going to type in -3 and see if that's true. And it turns out it is. At -3, the function does equal 0. So that spot's -3. This one looks like it might be 1, so let's try going to 1 and see. And yeah, it is. It's 1. So I have this spot at -3. I have this spot at 1. Knowing where those are, I can actually write the answer to this equation. Okay. It starts being above 0, greater than 0, at this spot. It starts at -3. I cannot include the -3, though, because at the -3, at this spot right here, it is at 0. It's not greater than 0. Our interval starts right there. And then it's greater than 0, it's greater than 0, it's greater than 0, it's greater than 0, all the way until we get to this spot right here, at 1. At 1, I have to stop again, the parentheses, because at 1 it's equal to 0, it's not greater than 0. All right. And then I put a union, and then I'm going to do another interval. This one's going to start at 1. It's going to start at this spot where it's equal to 0. And then it's going to continue forward. So it's going to continue on to infinity. And so these would be the intervals that satisfy this inequality. -3 to 1, union 1 to infinity. So that's how you do it graphically. You just graph the polynomial, and you just look for what part of the graph is greater than 0, or what part of the graph is less than 0, or whatever. Okay? I believe there is 1 or 2 of these on your assignments in my math lab, so just make sure you're okay with how to do them. Right. Now that's how you do it graphically. We can also solve these equations algebraically. And that's what our steps right here say. First off, rewrite the inequality so that it has 0 on the right-hand side. Okay? So it looks like one of these things. Step 2, solve the equation f of x is equal to 0. So replace the inequality with an equal sign and solve. The solutions you get are called the boundary points for your solution. They are the boundaries. Put your boundary points on a number line and use it to break your number line into intervals. Step 4, choose a test value in each interval to evaluate f of x at. Okay. If you get a positive, then that tells you your function is greater than 0 in that interval. If you get a negative, that tells you your function is less than 0 in that interval. Once you've finished making your number line and you've done all your test values, the last step is to write your solution set by selecting the interval or intervals that satisfy the original inequality. Okay. So let's look at some examples of this. Our first one asks us to solve and graph 2x squared plus x greater than 15. Right now we don't have 0 over here, so I do need to move the 15 over. And so I am going to have tablet is already acting up right here at the very beginning. We're going to have 2x squared plus x minus 15 greater than 0. Okay. So we have it as a 0 there. That's the first step. The second step we're going to do is we're going to replace the inequality with an equal sign. So we're going to say 2x squared plus x minus 15 equals 0. And then we want to solve that equation. Now, you can solve that equation any number of ways. I'm just going to do it with factoring. But you could do it with the quadratic formula, if you like. In order to make 2x squared, you would have to have 2x times x. To make 15, you can either have 1 times 15 or 3 times 5. I'm going to use 3 times 5. I'm going to put the 3 here and the 5 here. The reason why is 2 times 3 will give me 6. In the middle I have 5. And 6 and 5 can make the 1 that I have right here. The 6 needs to be a positive. The 5 needs to be a negative. So that's how it's going to look. Now that we have it factored, we can set the factors equal to 0. And we can solve each of those things. This one, when we solve it, we'll end up with x equals 5 over 2, which is the same thing as 2.5. This one, when we solve it, we'll get x equals negative 3. So these right here are our boundary points. Okay? So I'm going to construct myself a little number line. And on this number line, I want to make sure I include the boundary points. So I want to include negative 3, and I want to include 2.5. Now what I want to do is I want to pick a number. Well, first off, let me explain this. This breaks our interval, our number line, into 3 intervals. There's one that starts here at negative infinity and goes to negative 3. There's another one that goes from negative 3 to 2.5. And then there's our last one, which goes from 2.5 up to infinity. So what we want to do is we want to pick a test value in each of these intervals. So what is a number between negative infinity and negative 3? You can pick any number. I'm just going to use x equals negative 4. What's a number between negative 3 and 2.5? Again, you can pick any number between them. I'm just going to use x equals 0 because it's really easy to plug in. And then lastly, I need a number between 2.5 and infinity. You can pick any number. I'm just going to pick x equals 3. And so what we're going to do is we are going to take these numbers, these values, and we're just going to plug them into our function over here and see whether or not we get a positive or a negative. So I'm going to start with plugging in negative 4. So I have 2 times negative 4 squared plus a negative 4 minus 15. It comes out as a positive 13. So I'm just going to write down the positive. I don't really care that it came out as 13. I just really care that it came out positive. Alright, then I'm going to plug in 0. Now I don't even need the calculator for this because when I plug in 0, this term is going to become a 0. This term is going to become a 0. So I'll have 0 plus 0 minus 15. That's going to come out as a negative 15. So it's going to be negative. All right, and then plugging in 3. 2 times 3 squared plus 3 minus 15. That comes out as positive 6. So again, I just want to write down that it's positive. So there we go. I know that this function goes positive, and then negative, and then positive. So to pick out my answers, I need to satisfy the original inequality. The original inequality says that it needs to be greater than 0. Greater than 0 means positive. So I want the intervals where this is positive, I want this interval, and I want this interval. So my answer is going to be this interval, which is negative infinity to negative 3. Do I include the negative 3? No, because I don't have an equal to here, so it doesn't work. So I'm going to exclude the negative 3. And then I'll have union, and then I want to do this interval. This one starts at 2.5, again not included because the inequality doesn't include it. And then it goes on to infinity. And so that would be our answer. And then if we want to graph it, I'm going to be kind of lazy and just only put these numbers on. Here's negative 3. Here's 2.5. I want to go from negative 3 to infinity back this way. And then I want to go from 2.5 to infinity. There we go. There's my graph. I don't have the middle area shaded because we did not include that middle interval. So that's how that one works. All right, let's look at example 3. Example 3 asks us to solve and graph this inequality and, graph it. We have 4x squared less than or equal to 1 minus 2x. I don't have 0 on the right-hand side, so I'm going to take these things and move them over. So I will have 4x squared plus 2x minus 1, and that's going to be less than or equal to 0. Once I've made it a 0 on the right-hand side, I'm going to replace the inequality with an equal sign. So I'll have 4x squared plus 2x minus 1 equals 0. Now that we're here, we can solve that equation either by factoring or the quadratic formula. Try to see if this one factors really quick. I don't know if it does. I don't think it does. Let's do the quadratic formula really fast. So we'd have x equals negative b, so it'd be negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 4, times c, which is negative 1, all over 2 times the a, which is 4. So it's negative 2 plus or minus a square root. I'm going to figure out what's in there really quick. 2 squared minus 4 times negative 1. So the 20 that's in there. Over 2 times 4, which is 8. Let me simplify that 20. I'm going to do a little factor tree. 20 is 2 and 10. 10 is 2 and 5. So there is a pair of 2's there. So this is negative 2 plus or minus 2 square root of 5 all over 8. Since there's a 2 on the stuff on top, I could factor that out. If I pull out a 2, it leaves behind negative 1 plus or minus the square root of 5 all over 8. And then the 2 can cancel out with the 8, leave a 4 behind on the bottom. So we actually have two possible answers. We have -1 plus the square root of 5, and that gets divided by 4. And we have -1 minus the square root of 5, and that gets divided by 4. So there's my two boundary points. Now, they're really ugly boundary points, but they're okay. We'll deal with it. So let's create our number line. We're going to put these boundary points on. I don't know for sure where they are, so I'm going to go and figure out what numbers these are. So -1 plus the square root of 5. And I'm going to take that answer and divide it by 4. So this is approximately 0.3. And then the other one, -1 minus the square root of 5. And then take that answer and divide by 4. This is approximately -0.8. So this one is going to come first. We'll have -1 minus the square root of 5 over 4. And then over here I'll have the other one, which is -1 plus the square root of 5 over 4. We'll pick a test value in each interval. So this was about -0.8, so before that would be -1. In between these two, in between -0.8 and 0.3, I could use 0. And then after this one's 0.3, so after 0.3 I could use x equals 1. And then all you do is take those and plug them into our equation over here. So 4 times -1 squared plus 2 times -1 minus 1. That gives us a positive 1. Plug in 0. That's going to be a 0. That's going to be a 0 minus 1. It's going to come out negative. And then plug in 1. 4 times 1 squared plus 2 times 1 minus 1 gives us a positive 5. So this is a positive. So there's our intervals. Now we need to pick which one satisfies our inequality. Our inequality was a less than or equal to. Less than means negative. So that means I want this little interval here in the middle. So my solution is going to be -1 minus the square root of 5 over 4, comma, -1 plus the square root of 5 over 4. And then both of these are going to get included. Both of them are going to be in brackets. The reason why is we have the equal to. Equal to allows us to include our boundary points. So we will include those. Graphing it on a number line, again, I'm going to be kind of lazy. I'm just going to put those two numbers on there. So here's -1 minus square root of 5 all over 4. Over here is -1 plus the square root of 5 all over 4. I have a bracket, and I'm going to shade the area in between them because I want that middle interval that is between the two boundary points. And so that would be my graph. Okay. So there's how example 3 works. Okay. Here we've got a slightly longer one, example 4. This asks us to solve and graph the solution set on a number line, x to the third plus x squared less than or equal to 4x plus 4. Now again, I need a 0 over here on the right-hand side, so I'm going to take the 4x and the plus 4 and move them over. So I will have x to the third plus x squared minus 4x minus 4 less than or equal to 0. Now that I have a 0 there, I can change the inequality to an equal sign. So x cubed plus x squared minus 4x minus 4 equals 0. Now, in order to solve this one, this is a 4-term equation, so we're going to do factor by grouping. We're going to group these two and group these two. In the first group, in common between these two terms is an x squared. When I factor it out, when I pull an x squared out of x cubed, it leaves behind an x. When I pull an x squared out of x squared, it leaves behind a positive 1. In the second group, in the next group, if we look between these two terms, okay, in common between both of these is a minus 4. When I pull that out of this first term, it leaves behind an x. When I pull it out of this term, it will leave behind a plus 1. In common between the two groups is an x plus 1, so I will pull that x plus 1 out. When I do, from the first group, it's going to leave behind an x squared. And from the second group, it's going to leave behind a minus 4. Then I can take those factors and I can set them equal to 0. So x plus 1 equals 0. X squared minus 4 equals 0. Move the 1 over, so I get x equals negative 1. Over here, move the 4 over, I get x squared equals 4. And then I take the square root, and so I get x equals plus or minus 2. So I actually have 3 boundaries on this one. So when I put them in my number line, I'm going to put them in order. So I have negative 2, then I have negative 1, and then I have positive 2. So this one actually has 4 different intervals. I want to pick a test value in each one. In this first interval, I'm going to pick negative 3. In this second interval, I'm going to pick negative 1.5. In the third interval, I'll pick x equals 0. And in the last one, I'll pick x equals 3. And then all I got to do is take these numbers and plug them back here into my original equation and see whether it comes out positive or negative. So I've got negative 3 getting cubed plus negative 3 getting squared minus 4 times negative 3 minus 4. Gives me a negative 15, so that one is negative. And I'll plug in negative 1.5. Negative 1.5 getting cubed plus negative 1.5 getting squared minus 4 times negative 1.5 minus 4. That gives me a small positive, but still a positive. So positive. 0, I don't really need the calculator for. That's going to become a 0, that's going to become a 0, that's going to become a 0. So all I really have is the minus 4, so it's going to be a negative. So last I just need to plug in 3. So I'll have 3 getting cubed plus 3 getting squared minus 4 times 3 minus 4. And I get a positive 20. So that is a positive number. So now that I have this, I looked back at my inequality. My inequality was a less than or equal to. Less than means negative. So that means I want this interval and I want this interval. Because of the equal to, I can include my endpoints. So my answer is going to be negative infinity to negative 2 with a negative 2 included. And I'll put a union, and then I'll have negative 1 included to 2 included. And so that would be my answer. Graphing it, I'm going to plug these numbers on here. Here's negative 2. Here's negative 1. Here's positive 2. I have a bracket here on the negative 2, and I shade to the left to go to negative infinity. And then I have a bracket here on negative 1, and a bracket here on 2, and I shade between those two. And so that's what our solution set would look like. Anything over in this shaded part or anything in this shaded part would work to solve the inequality. Okay. So that is how we do polynomial inequalities. Inequalities that involve polynomial functions. Okay. The other thing we're going to look at today is solving rational inequalities. So here are our steps for solving rational inequalities. The first step is to make sure that one side is 0 and the other side is a single quotient, meaning it is a single fraction. Once you've done that, that's actually usually the hardest part. Once you've done that, the second thing to do is take the numerator and the denominator, the top and bottom of the fraction, and set them both equal to 0 and solve. Those will be the solutions that will give you your boundary points. Step 3, put your boundary points on a number line. Step 4, pick a test value and plug it in to see whether it's positive or negative. And then step 5, pick your solution set. Now, there is a little extra here when you pick your solution set. With the endpoints, with the boundaries, you have to check, 1, do they work with the inequality? And 2, do they work with the equation? What I mean by that is, if your boundary point would make the denominator, the bottom of the fraction, equal 0, then you cannot include them. They don't work. So you have to check your endpoints, check your boundaries. Alright, so let's look at some examples of this. So example 5 here asks us to solve and graph the solution set for x plus 1 over x plus 3 is greater than or equal to 2. First thing I want to do is I want to get a 0 here, so I'm going to move the 2 over. I'll have x plus 1 over x plus 3. Sorry, my x got a little bit messy there. Minus 2 is now greater than or equal to 0. Now, that's a 0, but the other thing I need is I need a single quotient over here, which means I need a single fraction. Right now I technically have 2 fractions. I have this one, and then I have this 2, which is technically over 1. In order to combine these into one fraction, I would need a common denominator. The common denominator is going to be x plus 3. So I'm going to multiply this one on top and on bottom by x plus 3. So what I have is x plus 1 over x plus 3 minus 2 times x is 2x, and 2 times 3 is 6 over x plus 3, greater than or equal to 0. Now that they have the same denominator, they can be combined together. So I copy down the denominator, x plus 3, and then on the top, I just perform the subtraction. So x minus 2x gives me negative x. 1 minus 6 gives me negative 5. That's greater than or equal to 0. So now I've finished step 1. I have 0 on the right side. I have a single quotient, a single fraction on the left. Now all I need to do is take the top of the fraction, negative x minus 5, and set it equal to 0, and take the bottom of the fraction, x plus 3, and set it equal to 0. On this one we would add the 5 across, so we'd have negative x equals 5, and then we would divide the negative across, and we'd have x equals negative 5. Over here we would move the 3 over with subtraction, so we'd have x equals negative 3. So these are our boundary points. We're going to put those on a number line. So Here's negative 5. Here's negative 3. I'll pick a test value in each interval. So here I'm going to pick x equals negative 6. Here I'll pick x equals negative 4. And here I'll pick x equals 0. And then we just plug them into this fraction. So on the top I have negative 6 minus 5, close the parentheses for the top, divided by, parentheses for the bottom, negative 6 plus 3, close the parentheses for the bottom. And I end up getting a negative number. Right, for negative 4, I have parentheses, negative 4, minus 5, close the parentheses for the top, divided by, parentheses for the bottom, negative 4 plus 3, parentheses, negative positive 1. And lastly, 0, parentheses for the top, negative 0 minus 5, close the parentheses for the top, divided by 0 plus 3, I got a negative number. So, here's my intervals. I look back at my inequality. It was a greater than or equal to, which greater than means positive. So that means I want this interval right here. So I want the interval that goes from negative 5 to negative 3. Now I need to talk about whether or not I can include my endpoints. Well, the inequality, it has an equal to in it, which means I could theoretically include my endpoints. But I need to check if I take an endpoint and plug it into the bottom of the fraction, is it going to make a 0 there? Because if it does, I can't include it. So if I take negative 5 and plug it in, negative 5 plus 3 gives me negative 2. That's not 0, so that's okay. So I can include negative 5. Negative 3, though, when I plug in, negative 3 plus 3, that would give me 0 on the bottom. I don't want 0 on the bottom, so I have to exclude the negative 3. Even though the inequality says I'm allowed to include the endpoint, because it makes the bottom of the fraction 0, I have to exclude. So there is my answer. When I graph this, here's how it's going to look. At negative 5, at negative 3. I'm going to put a bracket on this one and a parentheses on this one, and then I'm going to shade this area in between them. Okay. And so that would be my solution set. Okay. Got another one right here. Example 6 asks us to solve the inequality 3x squared plus 13x plus 9 over x plus 2 squared is less than or equal to 3. Now, I'm going to rewrite this really quick. X plus 2 squared is really x squared plus 4x plus 4. So I'm just going to act like that's not there. I'm just going to rewrite it like that. Now, in order to do this, the first thing I need to do is make this a 0 on the right-hand side. So I need to move the 3 over. So I'm going to have 3x squared plus 13x plus 9, all of that over x squared plus 4x plus 4. And I'm subtracting over that 3. I have less than or equal to 0. So I have the 0 there. But now the next step is I need to get a common denominator so I can combine these two fractions together. The common denominator is going to be this denominator, x squared plus 4x plus 4. So this first term is not going to change. It's still going to be 3x squared plus 13x plus 9 over x squared plus 4x plus 4. The second one, though, when it gets that denominator, when it gets that x squared plus 4x plus 4 on the bottom, that 3 also has to get this. So you're going to have 3x squared plus 12x plus 12. And that's less than or equal to 0. Now that they have the same denominator, combine them together. So I'm going to rewrite the denominator, x squared plus 4x plus 4. On the top, 3x squared minus 3x squared, those will cancel out. 13x minus 12x, that's just going to leave us with x. And then 9 minus 12, 9 minus 12 is negative 3. Less than or equal to 0. So at that point, we now have it down to one fraction. Once we have that, then we can take the top, which is x minus 3, and set it equal to 0. And then we can take the bottom, which is x squared plus 4x plus 4, and set it equal to 0. For this one, we would just add the 3 across, and so we would get x equals 3. For this one, you would want to factor. Now, luckily, we already know how it factors because they gave it to us as factors up here. It factors into x plus 2 squared. To get rid of the square, you take a square root. So you're going to have x plus 2 equals, the square root of 0 is 0. Then you would move the 2 over, so you get x equals negative 2. So there are our two boundary points. We're going to make our number line. So here I've got negative 2. Over here I've got positive 3. So in this interval, I'm going to pick x equals negative 3. And this interval, I'll pick x equals 0. And this interval, I'll pick x equals 4. Then we're just going to take those and plug them into our equation. So on top, I have negative 3 minus 3, close my parentheses for the top, divided by parentheses for the bottom, negative 3 getting squared plus 4 times negative 3 plus 4. Look at that, that comes out as a negative 6. So it's a negative there. Alright, 0 if we plug it in. We have on top parentheses 0 minus 3, close parentheses, divided by, on bottom parentheses 0 squared plus 4 times 0 plus 4, close the bottom parentheses. We also get a negative, so it's still negative. And then for 4, if we plug that in, parentheses 4 minus 3, divided by parentheses 4 squared plus 4 times 4 plus 4. And that comes out as a very small positive, but it is still a positive. So there's our solution set. If we look for our inequality, it's less than or equal to 0. Less than means we want negative. So that means I want this interval and I want this interval. Okay. So the first interval goes from negative infinity to negative 2. I'll have a union. And then the second interval goes from negative 2 to 3. And then I need to decide about whether or not I include endpoints. If I look at the inequality has an equal to, which means endpoints could be included. But I need to check them and see do they work or not. So if I took 3 and I plugged them into the bottom here, 3 squared is 9, 4 times 3 is 12, 9 plus 12 is 21, plus 4 is 25. That is not 0, so 3 could be included. So I'll put a bracket on 3. Let's check negative 2. If I take negative 2 and plug in, negative 2 squared would be 4. 4 times negative 2 would be negative 8. So I'd have 4 plus negative 8. So that's negative 4. Plus 4 more. That gets me 0. I can't have 0 on bottom. So negative 2 I cannot include. So I have to put parentheses on the negative 2's. And then the negative infinity is always a parentheses. So that goes like that. So there is my answer. There's my final solution set. And then when we graph this, here's negative 2. Here's positive 3. We're going to have a parentheses here on the negative 2, and it's going to go that way towards negative infinity. Then we'll also have a parentheses on negative 2 going the other way, and then we'll have a bracket on 3, and we'll have this area in between. Now, the little double parentheses on negative 2 tells you that negative 2 is not going to get included. Like, it's pretty much anything in this whole interval but negative 2. We just can't include that negative 2. Okay. So, there's how that one looks. We have one last application that we're going to look at, and this requires us to look at this equation. This is the equation that we use for what's called projectile motion, where an object is either thrown or launched into the air. What it says is that your height, s of t, is equal to negative 16 t squared plus v sub 0 t plus s sub 0. V sub 0 is the initial velocity, how fast you throw the object or launch the object or whatever. It's positive if it's launched or thrown up. It's negative if it's launched or thrown down. S sub 0 right here is the initial height of the object when it first gets launched or thrown or whatever. The t's that are here and here represent time. How much time in seconds has the object been moving? Okay. So in these problems, they're going to give you an initial velocity, they're going to give you v sub 0, and they're going to give you an initial height, s sub 0. And then you're going to do something with it. So let's look at our problem. Our problem says, a ball is thrown vertically upward from the top of the Leaning Tower of Pisa, which is 190 feet high, with an initial velocity of 96 feet per second. During which time period will the ball's height exceed that of the tower? Well, first off, let's write an equation for the ball's height. So say s of t equals negative 16 t squared, and then our initial velocity is 96, and it's upward, so that's a positive, so we'd say plus 96 t, and then our initial height is 190 feet, so it's going to be plus 190. So this is the equation for the ball, or rather for the ball's height. Okay. Now they're asking us to figure out during which time period will the ball's height exceed that of the tower. So we want the ball to end up being greater than the tower. We want it to exceed. Exceed means go above. So we want the ball to be greater than the tower. Well, if we fill in our equation for the ball, we have negative 16 t squared plus 96 t plus 190 greater than. How big is the tower? Well, again, the tower is 190 feet. So there is our inequality that we want to solve. To solve that inequality, the first thing we would do is we would get a 0 on this side. So we would move the 190 over. So we'd have negative 16 t squared plus 96 t. And when we move the 190 over, those cancel out. And so we should end up greater than 0. Now that we have a 0 over there, we can change this from an inequality to an equation. So we say negative 16 t squared plus 96 t equals 0. And then I want to solve that equation. Now, to make my life a little easier, I'm going to go through and divide everything by negative 16. So negative 16t squared divided by negative 16 is just going to give me t squared. My calculator over here, 96 divided by negative 16 gives me negative 6. So I have negative 6t equals 0 divided by negative 16 is still 0. Now that I've done that, this becomes a very easy equation to factor. I can factor out a t, and it would leave behind t minus 6. Set our factors equal to 0. We get t equals 0, and t minus 6 equals 0. For this one, we would add the 6 across, and we would have t equals 6. So these are our two boundary points, 0 and 6. So when we put them on our number line, here's our number line. We've got 0, and we've got 6. Now here's the thing. Numbers before 0 don't actually exist in this context, because in this context, we're talking about t, which is time. There is no such thing as negative time. We are not time travelers. So I really can't do anything with that interval before 0. So really, I have to start here at 0. So now I'm going to pick a test point at each of the intervals that remain. So between 0 and 6, I'll do t equals 1. And between 6 and infinity, I'll do t equals 7. Take those and plug them into your original equation, whichever one you want. Let's make sure we do this one right here with the equal sign. Okay, so we'll have negative 16 times 1 squared plus 96 times 1. That gives us a positive 80. And if we do 7, we have negative 16 times 7 squared plus 96 times 7. That gives us a negative 112. Yeah. So we have a positive and a negative. We'll go back to your inequality. It was a greater than 0, so that means you want a positive. So our positive interval is this interval right here. You want to see whether or not you include the endpoints. There is no equal to here, so we cannot include the endpoints. So this interval would be written as 0 to 6. If we wanted to write it in words, we would say between 0 and 6 seconds. And then we would say exclusive. It's exclusive because we don't want to include the 0 and we don't want to include the 6. So any time between 0 seconds and 6 seconds, that ball is going to be higher than the tower. After 6 seconds, it'll be below the tower. Okay? And so that's how that problem works. It's all pretty straightforward. So that is it for 5.4. As always, if you have questions, feel free to email me.